Good morning, everyone. So, in this morning, we will discuss about the comparing of boiling points and boiling points in solubility. So, comparison of boiling points. So, in compound, naash na ay propanol and sa second is propanol. So, number one, the compound name is propanol, in which they contain three carbons, and also the family name or the functional group is aldehyde. The molar mass of propanol is 58 and iyang boiling point is 49 degree Celsius. In propanol, the intermolecular forces present is dipole-dipole forces, while the propanol has the additions of having a hydrogen bonding which is slightly stronger. This means that the stronger forces between molecules means that more energy is required to break apart a molecule, and therefore the substance therefore um, the substance has higher boiling point. That's why ang propanol has a lower boiling point than propanol, kay it's because ang propanol kanang naa siya dipole-dipole attractive forces between sa molecule are much stronger. Then the stronger forces between molecule means that more energy is to break apart the molecule. That's why the boiling point of propanol is higher than the propanol. That's all.
Next is a comparison of boiling points between the methanoic acid, the propanol and the methanoic acid. Propanol na ang second, then methanoic acid. Methanoic acid is because isa lang ang iyahang uh, carbon hydrocarbons attached. Then we have the carboxylic carboxylic acid group. Then, OH, so kabulutab sa OH gani, alcohol na siya. Okay. Ang molar mass nila is same lang, but then the boiling point is nag-differ. It's because, ang tong kagaganiha kang Febi is dipole-dipole ang aldehyde, ang propanol. Ang si propanol is na siya hydroxyl group. So, na siya hydrogen bond. And then we'll know that the dipole-dipole is medium to moderate lang ang iyahang attraction sa ihang mga molecules, while ang hydrogen bonding mas taas ang ihang attraction, so mas strong ang attraction ni hydrogen bond. So diri sa carboxylic acid, so nakita nato na siya duha ka oxygen bond to carbon. Ang kabalotan na neutral, having two lone pairs and two bonds, di ba? So napa na siya lone pair si oxygen din ha. So duha ka buok oxygen ang sa atong carboxylic acid. So makita nato na between alcohol and carboxylic acid, between propanol and this methanoic acid, pareha sila na ay hydrogen bond. Pareha sila na ay hydroxyl group. But then, mas kusog ang boiling point ni methanoic acid. It's because mas taas ang ihang capability to pull electrons kung tapara nato siya og other carboxylic acid molecule. Kung dungagan na manapatay isa ka carboxylic acid molecule din ha, or methanoic acid molecule, mas kusog ang ilahang bonding. It's because of the presence of oxygen nga duha ka buok nga presence naa sa methanoic acid. So, mo na siya ay ang nakakuan sa iyaha nga kung mas taas ang hydrogen bonds niya, mas kusog mas paspas ang hydrogen bond sa isa ka molecule, mas taas pod siya og boiling point, mas dali siya mo bukal. So, that is man na siyang explanation nga no mas taas og boiling point si carboxylic acid than the alcohol family. Walang
So lastly, we will discuss about the boiling points and solubility.
So, good morning, everyone. I am Maria Angela Tagalog. What I am going to discuss is about the intermolecular forces that affects the boiling points of methanoic acid up to hexanoic acid. So, as you have seen about the boiling point of compounds from methanoic acid to hexanoic acid, those compounds are from a carboxylic group which their molecule can form a hydrogen bonding with water. So, and as belong sila sa carboxylic group, they have a high boiling point. And those compounds, which is the methanoic, ethanoic, propanoic, butanoic, benzenoic, and hexanoic acid, they have the strength of hydrogen bonding forces and a dipole-dipole interaction, where a carboxylic acid exhibit a strong hydrogen bonding between molecules. Therefore, they have a high boiling points. And all of these molecules are a polar molecule except sa hexanoic acid ay non-polar na siya. But they have the hydrogen bonding forces, which is the strongest type of intermolecular forces. So, tungod daw sa presence sa hydrogen bond that is relatively strong type of intermolecular forces, kailangan pa na sa uban nga like molecules mag take og energy para maguba ang bonds anang hydrogen bonding. So, ana ka strong ang hydrogen bond na naka-attach ato na molecules nga hinungdan maong high ang boiling points ato na molecules. And lastly, about the properties like boiling points, they are gina-measure sila og how strong the attractive forces between individual atoms or molecules. So, kana siya na property mo na atong ginatawag og intermolecular forces and forces between molecule as opposed to intramolecular forces and the forces within a molecule. And kana siya, naga-flow siya from general principles. And always keep in mind as bonds become more polarized, the charge on the atoms become greater, which leads to a greater intermolecular attractions and leads to a higher boiling points. So, kadto lang.
So, I'm going to discuss about the intermolecular forces that affects boiling points and solubility of hexanoic acid and benzoic acid. Between the molecules of carboxylic acids, there is a lot of hydrogen bonding. They have high boiling points. The water molecules quickly form hydrogen bonds with the carboxyl group. So, water is entirely miscible with acids with 1 to 4 carbon atoms. Very soluble daw ang water with acids pag ang carbon is isa lang ka buok, duha, tulo, and up to 4 carbon atoms. Because ang dipole forces daw become less important and the dispersion forces become more prominent or predominant. So as the carbon chain length grows, solubility declines. So motong ang hexanoic acid o ang benzoic acid kay ano siya kanang slightly soluble siya kay ang iya mas nagdaghan mas naggrows man ang iyahang carbon chain, so that why na ang iyahang solubility declines. Kani siya da ani ayopak name. But as you can see, sa methanoic acid, sa ethanoic, propanoic, and butanoic acid, ang ilang boiling point kay 101, 118, 141, 164. So, ang ilang solubility in water is ano siya, miscible or very soluble sila. Kay na lang man siya sa methane, 1 carbon, 2, 3, and 4. Na siya 1 up to 4 carbon atoms lamang. So, ang ilang water is very soluble siya. Then sa pentanoic ug hexanoic acid o pila sa benzoic kay ano sila slightly soluble sila. It is because the carbon chain length grows, so that's why the solubility declines. And then the intermolecular forces that affects the boiling points and the solubility is that ang dipole forces katong dariya kay naging less important o ang dispersion forces become prominent. So ang dariya vice versa siya. Ang dipole forces niya mas nag-important siya tapos ang dispersion forces niya dili na siya predominant. That's all. Thank you.
So good day everyone. My name is Alexandra Milka Dayona. I'll be explaining why the first to fourth carboxylic acids are very soluble and why pentanoic acids and other higher carboxylic acids are less soluble in water. Carboxylic acids are soluble in water. Also, carboxylic acids do not dimerize in water, but forms hydrogen bonds with water. Carboxylic acids are polar, and due sa presence sa the hydroxyl in the carboxyl group, magka-form siya hydrogen bonds with the water molecule. So, nganong mas soluble ang first to fourth carbon, which is ang methanoic to butanoic acid, mas soluble siya kay smaller carboxylic acid are soluble in water, whereas larger carboxylic acids ay carbon ay nga na ay unom ka carbon pataas, mas less soluble na siya due to the increasing hydrophobic nature of the hydrocarbon change. Meaning ang para sa methanoic acid, lower mass siya, mas soluble siya sa pag-ikuan mo siya sa water. Mas soluble siya sa water kay gamay raman niyang gram per mole iyang molar mass para sa methanoic acid compare sa pentanoic acid to benzoic acid. As you can see, yung boiling point kay taas mo nang dili lang mo'y basihan kay tungod ang boiling point sa molecule which is ang benzenoic acid to benzoic acid kay diba as you can see taas siya boiling point kanang makuan siya sa molar mass kay taas man ang molar mass sa benzenoic kung compare sa katong methanoic to butanoic acids kay iyang kuan naman para sa gingon ang giganiha yang carbon 1 to carbon 4 pas diba ang hexane kay na siya 6 ka carbon. In short, the acids with 1 to 4 carbons atoms are completely miscible with water. Solubility decreases as the carbon chain. So, magkataas yung carbon chain niya, magkababa, it become less important ang dispersion forces and it becomes more predominant. Okay. Pasok ko gingon ang molar mass lower molar mass mas soluble siya while katong mga tag-as nga molar mass mas kanang complicated gani. Okay na te, basin na kay kaad.
So, kung...
Di mo ko share.
Sige lang. So, kung magtaas ang carbon chain, so mas less ang iyang solubility in water, pero mas taas ang boiling points. It's because sa katong carbon chain, ang nagtaas ang carbon to hydrogen bonds. So, man na siya ang nakakuan sa pentanoic to benzoic acid. So, the more nga magtaas, the more less solubility siya. Pero taas ang ihang boiling points. Mm-mm. Lahi ang kuan sa carboxylic acid group sa alcohol, diba tong kakwa kaganihad. Pareha sila og molar mass pero mas taas gihapon boiling point si carboxylic or si methanoic acid. Do pareha sila og molar mass pero diri sa kaning carboxylic group kung magkataas ang molar mass, magka-less ang iyang solubility pero magkataas ang iyang boiling points.